We're looking at today is a GCE question. The diagram shows 8 identical regular octagons joined to enclose a shaded shape. Each octagon has sides of length A. Find in terms of an expression for the area of the shaded shape. Give your answer in the form P open bracket 2 plus radical 2 close bracket A square, where P is an integer. You must show all your working. So this is a very interesting question. So this is the form that we intend to attain for the area of the shaded region right here. Area of the shaded region right there. Now let's put it together. We were told that it's a regular octagon, which means that we definitely can apply some ideas here. So first, we were told all the sides are A. So we already know a lot. So this is A. This side here is also A. And the other sides are A. Now, in an effort to work this out, we want to establish this angle there. All right. So let us establish the angle. Let's take a look at this. If I should continue this side here, I'm going to actually have an exterior angle here and another exterior angle there. And they are identical because we have regular octagons and they are identical. Now, what happened is those are exterior angles. The total exterior angle of any polygon, it doesn't matter how many sides it has, is actually 360. So because it is 8 sides, it would have had 8 identical exterior angles. So if I divide this by 8, I'm going to get 45, which means that here is 45 and here is also 45. So we have an angle of 90 degrees there. All right. So let's just establish the fact that this is a right angle right there. So let us put that there. So we just established the fact that this is a right angle here. So all of those are right angle. Now let's take a look. Now this is A and this is also A. Now we can do this. I could cut these to show 4 identical triangles. These triangles would be of the same area. So remember now, because we have a right angle there, we can apply the area of a triangle, which is half base times height. And in this context, we're talking about A times A divided by 2, because our base and our height would have been A. So that's my base, that's my height, or vice versa. So what we're actually looking at here is actually half A square. And this is representing the area of one of these triangles. But remember, we have 4. So those 4 triangles that we establish, it's going to be 4 times half A square. And we're going to end up getting, when we cancel here, we're going to get 2A square. So we have now found these in terms of A, all 4. So what happened now, we're going to end up with a square. So this square that we're looking at, we also were given certain stuff because this is also a side, and this is also a side. So we can see that I have the sides of the square except this piece that I'm about to highlight right here. So if I could find this, I'm going to actually have one side of the square. And the moment I find one side here, then all the other sides would be identical to that because that's what a square is. Now let us put this together, right? Now let us take a look at our triangle that we have here. Let's put it here. This triangle that I have, okay, looks like this. So this is A and this is A. That means I can apply the Pythagorean theorem to find the longest side here, which would have been this side I have in blue there. So that simply can be worked out. Let us say I represent it at X for now. So if we're calling this X, we are saying that that side X is going to equal to the square root of A square plus A square. And this is actually gonna give us the square root of 2A square, and that's basically root 2A. or you could say a root 2. All right, so I like to put it like this. It's a square root 2. So let's label this here. So one side of the square, just one side, let me put it here, one side, right, of the square. One side of the square can easily be found by adding the pieces. A plus A, so this A plus this A, that's going to give me 2A. So I definitely have 2A plus A root 2. That's the length of one of the side of the square. So basically what I'm suggesting here is that one of the sides of the square in the middle is actually this, 2A plus A root 2. So that's one side. Remember, because it's a square, all the sides are the same. So now I need to find the area of the square, and that will be added to this area for those triangles. So let us try to find the area of the square right about now. Let's put that together. So the area of the square is going to equal to 2A plus A root 2, and we're going to multiply that by itself. You could square it, or you could represent it as a binomial here. So basically, we could FOIL this out. What do we mean? We're going to multiply 2A times 2A, then we go like that, then this times this, and that times that. So let us FOIL this out. 2A times 2A will give me 4, but A to the second. When 2A is multiplied by A root 2, I'm going to have 2A squared with A root 2. And then when this A root 2 is multiplied by 2A, I'm going to get the same thing. I'm going to get 2A squared and then the root of 2. And finally, when A root 2 is multiplied by A root 2, I'm going to end up having 2, because when the root 2 multiplied by root 2, it becomes 2. So I'm going to get 2, but the A times the A will be A squared. So let us put the like terms together. Definitely we're seeing where we have 4A squared and 2A squared, and that's going to give me 6A squared. And here I have 2A square root 2, 2A square root 2, so that's going to give me 4A squared, the root of 2. And this is for the area of the square. Now I need to add the area of the triangles. So that was already right here, it was actually 2A squared. So let's add these together. So when I add those together, I'm going to actually have 8A squared plus 4A squared square root of 2. So basically, that's what I have. But remember the form that they asked us to represent this in. We're supposed to show the area in this form right here. So basically, I'm going to factor out 4A squared. So let me factor that out. So I'm going to take out 4A squared. When I divide it into this, I'm going to have 2. When I divide it into this, I'm going to actually have plus root 2. But definitely, I need to have A squared at the back. So I'm going to split these. So I'm going to have the 4 being left at the front, 2 plus the square root of 2, and put the A squared at the back. Hence, we would have achieved the idea where P is actually 4 as an integer as suggested in the question. So there we go. The area of the shaded region right here was proven. Thank you for watching DellyMaths Concepts. Like the video, share it, and subscribe to the channel. See you next time.